Unveiling the secrets of the X-37B Spaceplane, mission OTV-8 and beyond. In a move that's sure to stir up some controversy, the U.S. Space Force is gearing up for the 8th test flight of the secretive X-37B Spaceplane. This mission, designated Orbital Test Vehicle 8, OTV-8, is scheduled to take off on August 21st with the Boeing-developed X-37 aircraft at the helm. But here's where it gets interesting. This mission is designed to test key navigation and communication technologies that could help U.S. aircraft and aerospace vehicles operate even as enemies deny GPS navigation and radio-based communication. Talk about a game changer. Boeing has been working on the X-37 since 1999, but it didn't take its first flight until 2010. This long-term orbital craft is entirely reusable and recoverable, much like the space shuttle that inspired its design. It's also the smallest and lightest orbital spaceplane yet flown, and it's already demonstrated its resilience to spacebound dangers and long-term reliability by remaining in orbit for over 900 days. The next launch is scheduled to take place within the next few weeks, though an exact date has not been confirmed. It will see the latest version of the spaceplane, the X-37B, launching atop a Falcon 9 Block 5 rocket for the first time. One of the key components of this launch is testing redundancies, as military conflicts have increasingly leveraged denial technologies like GPS and radio jamming. The X-37B will perform key tests on technologies that can still operate in these environments. One of them will be a GPS-free navigation system that uses a quantum inertial sensor. Operating like a traditional accelerator and gyroscope, the system will be far more accurate thanks to its ability to track the quantum properties of atoms. But that's not all. This flight will also incorporate a secondary experiment aimed at testing laser-based communications. Think of this a little like tight beam technology, in which a laser beam conveys information in a direct line to a receiver, rather than using more traditional wireless radio-based communications. It will leverage a network of inter-satellite laser communications systems, highlighting the Space Force's resilience to interrupted communications. And this is the part most people miss. This flight will also be part of continuing posturing between the United States and China, which has its own reusable spaceplane program. Known as the Shenlong, it has also demonstrated long orbital survival, runway landings, and a range of undisclosed payload transportation capabilities. So, what do you think? Is this a necessary step in the evolution of space technology? Or is it a dangerous escalation of military power? Space Force's X-37B OTV-8 mission. Laser comms, quantum sensors explained. Imagine a spacecraft so secretive that even its missions are shrouded in mystery. That's the X-37B, the Space Force's uncrewed spaceplane, which is gearing up for its 8th journey into the great unknown. Set to launch on August 21st from the Kennedy Space Center in Florida. This 9-meter-long marvel will hitch a ride on a SpaceX Falcon 9 rocket, marking a swift turnaround from its previous mission that concluded this spring. But here's where it gets controversial. While the Space Force has disclosed some details, many aspects of the mission remain classified, leaving us to speculate about the true extent of its capabilities and objectives. The X-37B is known for its marathon stays in orbit, with its longest mission lasting an astonishing 908 days. However, its most recent flight, OTV-7, was notably shorter, clocking in at just 434 days. But this is the part most people miss. Despite its brevity, OTV-7 achieved several significant milestones, including testing innovative braking maneuvers and capturing a photograph from space for the first time. The upcoming mission, OTV-8, will focus on experimenting with new technologies and conducting orbital tests, with a particular emphasis on laser communications and a quantum inertial sensor. Laser communications, utilizing specific wavelengths, offer enhanced security and data transmission capabilities compared to traditional radio communications. This technology could revolutionize how we communicate in space, making our satellite networks more resilient and adaptable. And this is where things get interesting. The quantum inertial sensor is designed to help the spacecraft navigate and track its position independently, relying solely on its own movements. This capability is crucial in scenarios where enemy electromagnetic jammers might disrupt GPS navigation, ensuring the spacecraft remains operational even in the face of electronic warfare. The U.S. military currently operates 2 of these Boeing-manufactured spaceplanes, which have been progressively extending their mission durations. The X-37B, initially developed by the Air Force and later taken over by the Space Force, has been pushing the boundaries of what's possible in orbital warfare. The Space Force is actively expanding its satellite arsenal and exploring the potential of space-based weapons, both kinetic and non-kinetic, such as lasers. While the X-37B is currently uncrewed and officially unarmed, artistic renderings by the military hint at future offensive applications. So, what do you think? Could the X-37B be the key to dominating the final frontier? Or is it just a high-tech distraction? Share your thoughts in the comments below, and let's dive into the debate. Boeing X-37B spaceplane launches on historic 8th mission. Boeing's X-37B spaceplane prepares for its 8th voyage into the cosmos. The highly anticipated launch of the X-37B Orbital Test Vehicle (OTV) is set to take place from the Space Coast in Florida, with liftoff scheduled no earlier than August 21st. This upcoming mission, known as OTV-8, follows just 6 months after the successful conclusion of its predecessor, OTV-7. The X-37B not only shows remarkable adaptability, but also showcases our commitment to diverse experimental missions as it explores new orbital terrains with each flight, stated Michelle Parker, who serves as the Vice President of Boeing Space Mission Systems. With OTV-8, we are continuing this rich legacy by introducing state-of-the-art technologies that enhance our nation's capabilities in space while fortifying future systems' resilience. OTV-8 is set to carry a service module that will enable a broader range of experiments and pave the way for further collaboration with mission partners, which include entities like the Air Force Research Laboratory and the Defense Innovation Unit. One of the mission's highlights will be the demonstration of advanced intersatellite laser communications technology with high data transmission speeds. Furthermore, it will also feature the most advanced quantum inertial sensor to have ever been utilized in a space environment. The U.S. Space Force aims to apply insights gleaned from this mission to inform its future frameworks for space operations. General Chance Sotzman, Chief of Space Operations for the U.S. Space Force, explained that the laser communications demonstration during OTV-8 represents a critical advancement in the U.S. Space Force's ability to integrate commercial space networks into a decentralized, robust, and flexible space architecture. This strategic approach is designed to reinforce the integrity, reliability, adaptability, and speed of data transport across satellite communication systems, which is increasingly vital in current and future missions. The state-of-the-art quantum inertial sensor will provide exceptional capabilities for positioning, navigation, and timing, especially in situations where GPS signals are unreliable or unavailable. This technology is particularly useful for navigation in deep space and within the vicinity of the Moon. As we strive toward deeper space exploration, such advancements are crucial for extending our reach into the cosmos. OTV-8's demonstration of the quantum inertial sensor marks a crucial advancement in enhancing the navigational capabilities of our guardians in space, remarked Colonel Ramsey Halm, the commander of Space Delta 9. Whether we're operating beyond Earth's orbits, such as in the cislunar space, or in environments where GPS is not available, these enhanced navigation capabilities ensure that we can effectively maneuver and operate without relying on traditional GPS methods. Thus, this technology plays an important role in the objectives of the 5th Space Operations Squadron and the broader Space Force, enabling effective movement even in challenging environments. Preparations for the launch are underway at Boeing's facility at Kennedy Space Center in Florida, where the X-37B has etched a remarkable legacy since its first flight in April 2010, accumulating over 4,200 days in orbit. Boeing, a top-tier global aerospace company and a leading U.S. exporter, works diligently to develop, manufacture, and service a wide range of commercial aircraft, defense products, and space systems for clients across more than 150 countries. The company's dedicated workforce and supplier network drive innovation while contributing positively to the economy and the communities it serves. Boeing prioritizes a culture founded on the core values of safety, quality, and integrity.